We'll start with an introduction to vectors. A vector is a quantity that has both magnitude and direction. It's customary to represent a vector by using an arrow because we can say that the length of the arrow represents the magnitude or the size of the vector, and the arrowhead, or which way it points, indicates the direction of the vector. So if we look at this picture here, we can say that this length here is the magnitude. And then how do we quantify the direction? Oftentimes we say that we look at what angle it would make in standard position. Two vectors that are equal have the same magnitude and direction. So in the figure to the right, we'd say that the vector PQ, which we just make by naming the starting point and the ending point, the vector RS and the vector TU are all equal, even though they have different initial points and different terminal points. So where they start and where they stop is different. So why would we say that they are equal? Well, they're all equal because they all have the same length. So they all have this same length here. And if we drew a horizontal for all of them, they would all make the same angle with the horizontal. And that's enough to say that they are equal. So given an initial point 0, 0, that's the origin, and a terminal point AB, a vector may be represented by AB. A vector in this form is in standard position, and it's called a position vector. So these are terms that we'll want to remember. And then this is a key thing. Two vectors with the same position vector are equal. Okay, so we'll have to keep our eye out for that. We can represent a vector with one letter, and you'll see sometimes it's in bold or italics, and then sometimes it has a little arrow on top as well. And those are all ways that we can represent a vector. So if we want to look at a position vector that with a known initial point and a known terminal point, then we can describe that with a position vector by just subtracting the ending x value minus the initial x value and the terminal y value minus the initial y value. So let's look at this exercise. The vector starts at the point 2, 3 and ends at the point 6, 4. Find its position vector. Okay, so this vector that's being described does not start at the origin, but what a position vector is really saying is if the vector started at the origin, then what would its terminal point be? That's another way of thinking about a position vector. So we don't have a name for it, but we can certainly call it, say, V. And then I'm just following what it tells me. It says x2 minus x1. So x2 minus x1 for the first position, and then y2 minus y1 for that second position. And so this gives us the vector 4, 1. So if we looked kind of at a quick sketch, okay, so if we have the point 2, 3, and then the point 6, 4, kind of look like that. And what we just said is if I picked up that point and moved it to the origin, its terminal point would be, if I could draw a little bit better, it should end at 4, 1. Now show that the vector v with this initial point and terminal point is equal to vector u with this initial point and terminal point. So how can we show two vectors are equal? Well, so far we said that two vectors are equal if they have the same position vector. So let's give it a try. So the position vector for v, all right, -1 minus 5, and then 2 minus a -3. And then at the same time, we've got u going on, which is -7 minus a -1, and then 2 minus -3. Okay, so now just kind of a simple, what are we doing here? -1 minus 5 is -6, and then 2 minus a -3, of course, is just +3 is 5. And then over here we have a -7 minus a -1 makes -7, right? This all is +1, so -6, and then 2 minus a -3, again, is just 5. So since they have the same position vector, we can say, why don't we say U and V are equal. Now, before we said that we have vector is a quantity that has both magnitude and direction. So the magnitude of the vector we can write as the symbol here, and this is how we find it. And then the direction can often be described by the angle it makes with the positive x-axis, just like we looked at before. So let's do an exercise where we find the magnitude and direction of the vector with some initial point and some terminal point, and those are both given here. Okay, so the first step here, I'm going to find the position vector. So if I find the position vector, now we're pretty good at this. I'm going to name this vector v, and I'm going to say this is -2 minus a -8. Oops, ended too soon here. Comma, and then the y, terminal minus initial y, so -5 minus 1. Simplify that, I get -2 plus 8 is 6, -5, take away 1 is -6. So there's my position vector. Now it says, okay, well, if you have some position vector, right, this is what's given here, well, then you can find the magnitude, which is really just the length, as the square root of a squared plus b squared. This is just taking into account the Pythagorean theorem and using that. So I can say, great, the magnitude is square root of 6 squared plus -6 all squared. Well, that's the square root of 36 plus 36, and the square root of 72 simplified is 6 root 2. So that's the magnitude. That's how we would find that. And if you could picture this vector, right, like we did that kind of quickly, but the position vector is, oops, I guess I need a different quadrant here, is 6, -6. So that means that this point is 6, -6, and the vector starts at the origin and then ends at that point. And if I'm trying to find the length, which is the magnitude, then I could certainly set up a right triangle that would go here, here, here. And then if I'm trying to find this length here, which I'm calling this magnitude symbol here, well, this is 6 and this is -6. And then if I'm, again, trying to find the hypotenuse, I'm just using Pythagorean theorem for that. Okay, what is the last thing? It says, find the direction. Okay, so this is the magnitude. And then if I want to find the direction, okay, I'm going to draw that again. Here's this guy. And a good way of finding that angle is really, again, like what would this angle be in standard position? So what would this angle theta be? I can see this is on the main 45-degree angle, so I could just, kind of use my unit circle and things to do that. But I could also just say that, if I wanted to know, say, what this angle was here, okay, I'll call it alpha. If this is 6 and this is -6, then the tangent of alpha is just opposite over adjacent. So if the tangent of alpha is just equal to -1, then alpha would just be -pi/4. Now, if I'm really after the angle in standard position, then I just do a little trigonometry, from the before times and just say, okay, well then, what would this angle B, that would be, all the way around, which would be just in the positive direction there. So we would say, this implies that theta would be, 7 pi over 4 if they wanted it to be, say within 0 to 2 pi. We could also give it in degrees. It really just depends on what's being asked for.